Hello everyone, welcome to this part of tutorial about sequences and series. In our previous part we discussed about geometric progressions where we found the formula for the nth term of a geometric progression, which is an equals a1 times r to the power n take away 1, and we found the formula for the sum of the first n terms, which is Sn equals a1 bracket 1 take away r to the power n over 1 take away r, where a1 is the first term and r is the common ratio, provided that r is not equal to 1. So in this part of tutorial we are going to learn about convergence of series, the sum to infinity of a geometric progression, arithmetic mean and geometric mean. Convergence of series. If a piece of string of length L is cut up by first cutting it in half and keeping one piece, then cutting the remainder in half and keeping one piece, then cutting the remainder in half and keeping one piece, and so on. The sum of the lengths retained is L by 2 plus L by 4 plus L by 8 plus L by 16 plus so on. As this process can be carried on indefinitely, the series formed above is infinite. After several cuts have been made, the remaining part of the string will be very small indeed, so that the sum of the cut lengths will be very nearly equal to the total length L of the original piece of string. The more cuts that are made, the closer to L the sum becomes. That is, if after n cuts the sum of the cut lengths is L by 2 plus L by 2 square plus L by 2 cube up to L by 2 to the power n, then as n tends to infinity, L by 2 plus L by 2 square plus up to L by 2 to the power n tends to L, or limit of the series where n tends to infinity equals to L. Here L is called the sum to infinity of this series. In general, if Sn is the sum of the first n terms of any series, and if limit of Sn where n tends to infinity exists and is finite, the series is said to be convergent. In this case, the sum to infinity S infinity is given by S infinity equals to limit of Sn where n tends to infinity. Thus, for example, the series L by 2 plus L by 2 square plus L by 2 cube and so on is convergent as its sum to infinity is L. But the series 1 plus 2 plus 3 plus 4 plus up to n has a sum given by Sn equals to half n times n plus 1. So as n tends to infinity, Sn tends to infinity, and this series does not converge. It is said to be divergent. For any arithmetic progression, Sn equals to n by 2 times 2a plus n minus 1 times d, which always approaches infinity as n tends to infinity. So any arithmetic progression is divergent. The sum to infinity of a geometric progression. So the series discussed earlier was L by 2 plus L by 2 square plus L by 2 cube and so on. It's a geometric progression whose first term is half of L and whose common ratio is half. So its sum to infinity, which we have seen is L, can also be found using the alternative method below. So we are going to use a different method to find out the sum of the n terms. So we know the general equation for the sum of the n terms of a geometric progression, which is Sn equals to a times 1 take away r to the power n over 1 take away r. So for this series, we are going to substitute the relevant values of common ratio and the first term in the equation, so that we will get an equation like this, where Sn equals L times 1 take away half to the power n. So when n increases, half to the power of n decreases. So this is because half is less than 1, and when we times half by half, we get a lesser value than half, which is 1 by 4. And also when we multiply 1 by 4 times half, we get 1/8, which is less than 1/4. So as we multiply by half each time, the value gets smaller than the previous. So that's how half to the power of n goes to 0 as n goes to infinity. So we can write it as limit of L bracket 1 take away half to the power of n, where n tends to infinity, equals L. Because this part of the expression goes to 0 as n goes to infinity. So we get the answer as L. So Sn tends to L as n tends to infinity. That is S infinity equals L. So this approach can also be applied to the general geometric progression a plus ar square and so on, where Sn equals to a times bracket 1 take away r to the power n over 1 take away r. So we have two conditions where modulus of r is less than 1 and modulus of r is greater than 1. So if modulus of r is less than 1, then the limit of r to the power n where n goes to infinity equals 0. So for example, when r equals half, we got 0 as limit of r to the power n where n tends to infinity. And limit of Sn where n tends to infinity equals limit of a times bracket 1 take away r to the power n over 1 take away r where n tends to infinity equals a over 1 take away r. So that is because r to the power n goes to 0 as modulus of r is less than 1. So the next condition is when the modulus of r is greater than 1. The limit of r to the power n where n tends to infinity equals infinity. As the sum value equals to infinity, this series does not converge. Therefore, provided that mod of r is less than 1, a geometric progression converges to a sum of a over 1 take away r. That is, for a geometric progression, S infinity equals to a over 1 take away r if and only if mod of r is less than 1. Arithmetic mean. So if three numbers p1, p2, p3 are in arithmetic progression, then p2 is called the arithmetic mean of p1 and p3. So if we have three consecutive numbers in the arithmetic progression like p1, p2 and p3, the middle number is called as the arithmetic mean of the other two numbers. So if p1 equals to a, we may write p2, p3 as a plus d, a plus 2d respectively. And p2 equals a plus d. So a plus d can also be written as half of 2a plus 2d. So which is the same as a plus d. So we arrange in such a way, and 2a plus 2d equals to p1 plus p3. So that is because p1 equals to a and p3 equals to a plus 2d. So a plus 2d equals to 2a plus 2d. So that's how we get p1 plus p3 over here. So p2 equals half of p1 plus p3. So that is the arithmetic mean of two numbers x and y is half of x plus y. Geometric mean. If p1, p2, p3 are in geometric progression, then p2 is called the geometric mean of p1 and p3. So the middle term is considered as the geometric mean of the other two terms. So say if p1 is a, then we may write p2 equals ar, p3 equals ar square. So say the arithmetic progression is ar, ar square. So the first term p1 equals to a, and second term p2 equals to ar, and the third term is ar square. So p1 times p3 equals a times ar square. So which is a square r square equals p2 square. So p2 equals root of p1 times p3. That is the geometric mean of two numbers x and y is root of xy. So if you consider the summary of arithmetic mean and geometric mean, for arithmetic mean we add the first term and the third term and divide by 2. For geometric mean, we times the first term and the third term and we find the root of the result. Determine whether the series given below converge. If they do, give their sum to infinity. So the first series which we have is 3 plus 5 plus 7 and so on. So we know it is an arithmetic progression where the first term is 3 and the difference between two consecutive terms is 2. So we learned that all arithmetic progressions are divergent. So 3 at 5 at 7 and so on is also a divergent series. So it does not converge. But if you consider the next series, which is 1 take away 1 quarter plus 1/16 take away 1/64 plus so on. So the common ratio here is -1/4. The first term is 1. So each time the terms are multiplied by -1/4. So if you look at the series can be written in such a way where we get the terms in powers. So -1/4 to the power of 2 at -1/4 to the power of 3 and so on. So this geometric progression where r equals -1/4, so the modulus of the common ratio is less than 1. So which means there is a finite value for the sum of the terms in this geometric progression. So the series does converge to a over 1 take away r, where we substitute the values, so we get 1 over 1 take away -1/4, which equals to 4 over 5. To find a series whether it is an arithmetic progression or geometric progression, say this series is an arithmetic progression. So in order to confirm that, we need to take away the previous term from the next term. So for example, if you take away the first term from the second term, which is 5 take away 3, we get 2. Similarly, 7 take away 5 equals 2. So we can confirm that the difference between all the consecutive terms is the same. Therefore, this is an arithmetic progression. Similarly, if we need to confirm that this is a geometric progression, we use division. You divide the next term by the previous term. So the second term given here is 9/2, and you divide that term by the previous term, which is 3. So if we divide that, we get 9/2, and the division becomes a multiplication, and when that happens, the denominator becomes the numerator and the numerator becomes the denominator. So as we are dividing by 3, it now becomes 1/3. So 3 goes into 3 once, 3 goes into 9 thrice. So we get the answer as 3/2. So we can confirm only when the same common ratio is got for the next calculation as well. So next we'll be working out 27/4 divided by 9/2. So 27/4, the division becomes multiplication. So we get 2/9. So the numerator becomes the denominator and the denominator becomes the numerator. So 2 goes into 2 once, 2 goes into 4 twice. 9 goes into 9 once and 9 goes into 27 thrice. So again we are getting 3/2. So we can confirm that the common ratio of this geometric progression is 3/2. And if you look at the second term, we multiply the first term by 3/2 to get the next term. So 3 can be taken out as a factor. So if we work out, we can get 3 plus 3 times 3/2 plus 3 bracket 9/4. As 3/2 is the common ratio, we can take the 3/2 in powers. So if you consider the modulus of the common ratio, 3/2 is greater than 1. So the series does not converge, which means this is a divergent series. So we can't find the sum to infinity for this series. Find the condition x so that sigma of x take away 1 whole thing to the power of r over 2 to the power of r, where r goes from 0 to infinity converges. Evaluate this expression when x equals 1.5. So we are asked to find the condition for series converges. So first let's expand the expression. So substituting 0 for r, would give us x take away 1 to the power 0 over 2 to the power 0. So any number with a power of 0 is 1. So we get 1 plus, so when we substitute 1 for r, we get x take away 1 to the power of 1 over 2 to the power of 1. So we get 1 plus x take away 1 over 2 plus x take away 1 over 2 whole thing to the power of 2, and so on. So the common ratio is x take away 1 over 2. For the series to converge, the modulus of x take away 1 by 2 to be less than 1 for the series to get converge. So if it is modulus, value inside the modulus can be negative or positive. So that we can write the next step as x take away 1 over 2 is in between negative 1 and 1. So we get an inequality. Now solving this inequality for x, we get the necessary values for x for which the series converge. So if you work out further, you get negative 2 less than x take away 1 less than 2, where we have multiplied by 2. And by adding 1 to each of them, we get negative 1 less than x less than 3. Now we are asked to evaluate the expression when x equals 1.5. So the value 1.5 is in between negative 1 and 3. So any values between negative 1 and 3 for x gives a convergent series. So 1.5 is in between negative 1 and 3. So by substituting x equals 1.5 in the expression, we get the expression equals to sigma 1 by 4 to the power of r, where r goes from 0 to infinity. So we substitute 0, 1, 2, 3 for r, so that we get the series like 1 plus 1 over 4 plus 1 over 4 whole thing to the power of 2, and so on up to infinity. So now we need to find the sum of the n terms of this series. So the series has a common ratio of 1 by 4, which is less than 1. So since the modulus of the common ratio is less than 1, the sum of the terms up to infinity would give us a over 1 take away r. So we get 1 over 1 take away 1 quarter, which equals to 4 by 3. So we have used the conditions s infinity equals a over 1 take away r, where r is the common ratio, which is 1 by 4, and the first term is 1. Now pause this video and work out this question by yourself. Express the recurring decimal 0.1 recurring 576 as a fraction in its simplest form or in its lowest terms. So the solution is, first we expand the recurring decimal, which would give us 0.1 recurring 576 equals to 0.157, 657, 657, 657, and so on. Now if you look at this expanded decimal number, the digits 576 are recurring. So what we do first is to partition this decimal in a way to make it simple. So 0.1 is taken separately. So we get 0.1 plus 0.0576 and so on. So now the number has been partitioned in a way to make it easier to convert them into fractions. So the fraction of 0.1 is 1 over 10. And to find out the fractions of other decimal numbers, what we do is to find out what would make the decimal number into a whole number. So the second decimal number has 4 decimal digits. So we times by a power of 10 so that we can make 0.0576 into a whole number. So that would be done by multiplying it by 10,000. Where 10,000 has 4 zeros, which is a quick trick to find out the number by which we need to times the decimal number in order to get a fraction. So 10,000 is equivalent to 10 to the power 4. So we times the number by 10 to the power 4 and we divide by the 10 to the power 4. So if we times the number 0.0576 by 10 to the power 4, we get 576. So the opposite needs to be done. So that we divide it by 10 to the power 4. That's what we have got as the denominator here. Similarly, to convert 0.00000576 into a whole number, we need to times it by 10 to the power 7. So if we are timesing by 10 to the power 7, we need to divide it by 10 to the power 7 in order to make decimal number equivalent to the fraction. So we get 576 over 10 to the power 7. And similarly, we need to times fourth decimal number by 10 to the power 4. So we get a denominator of 10 to the power 10. So if you look at this set of fractions, 1 over 10 is taken separately. You can notice that 576 is common to all the other fractions. And also 10 to the power 4 is common to all the other fractions. So we take 576 over 10 to the power 4 as a common factor from all of the terms. So we'll be getting the next step as 1 over 10, 576 over 10 to the power 4, bracket 1 plus 1 over 10 cube plus 1 over 10 to the power 6, and so on. So now we have got two terms here, and with the second term, there is a series to be multiplied. So by finding the sum of the n terms of the series, we can find out final fraction for this recurring decimal. So in order to do that, the first term of this series is 1, and the common ratio is 1 over 10 cube. And the modulus of r is less than 1. So since the modulus of the common ratio is less than 1, this series is convergent. So as this is convergent, we can find the sum to infinity for this series, which would be S infinity equals to A over 1 take away R. So by substituting the values 1 and R. So if you look at the value of R, 1 over 10 cube, can also be written as 10 to the power negative 3. So when the power in the denominator goes to the top, it becomes a negative power. So we get 1 take away 10 to the power negative 3. And if you simplify this expression, you get 10 cube over 999. Therefore, the sum to infinity is 10 cube over 999. And now we can substitute the sum to infinity instead of the series over here. So if we do that, we get 0.1 recurring 576 equals to 1 over 10 plus 576 over 10 to the power 4 times 10 cube over 999. So if you simplify this further, we get 1 over 10 plus 576 over 9990, which equals to 1575 over 9990. As we are asked to find the fraction in its simplest form, further simplification would give us 35 over 222. The third term of a convergent geometric progression is the arithmetic mean of the first and the second terms. Find the common ratio, and if the first term is 1, find the sum to infinity. So let me underline the important keywords. The third term of the convergent geometric progression is the arithmetic mean of the first and the second terms. So we can create a formula so that the third term of the convergent geometric progression is the arithmetic mean of the first and the second terms. Say the geometric progression is a plus ar plus ar square plus ar cube, and so on. So since the third term of the progression is equivalent to the arithmetic progression of the first and the second terms, so the third term in this progression is ar square, and the arithmetic mean of first and the second terms would be equivalent to half of the addition of the first and the second terms. So the first and the second terms are a and ar. So ar square equals to half of a plus ar. By simplifying, we get 2r square take away r take away 1 equals to 0. So we have taken off the a, which is common to all of these terms. And by factorizing this quadratic equation, we get 2r plus 1 times r take away 1 equals to 0. So therefore 2r plus 1 equals to 0, or r take away 1 equals to 0. So r equals to negative 1 half, or r equals to 1. And it is said the series is convergent, which means the modulus of the common ratio needs to be less than 1. So out of these two values which we have got, negative half and 1, where the modulus of negative half is less than 1. So we have to consider negative half as a suitable common ratio for this series. We are given that the first term is 1 and the common ratio is found as negative half, so that the sum to infinity is a over 1 take away r, whereby substituting the values in the equation, we get s infinity equals to 1 over 1 plus 1 half. So simplifying this expression would give us 2/3 as the answer. So that is the sum to infinity of this geometric progression is 2/3. So that's it for this tutorial. I hope you enjoyed learning about convergence of series, sum to infinity of a geometric progression, arithmetic mean and geometric mean. So in convergence of series, we learned that all arithmetic progressions are divergent series, as the sum to infinity of any arithmetic progression is infinity. But a geometric progression can be a convergent series or can be a divergent series. So that depends on the modulus of the common ratio of the series. If the modulus of r is less than 1, then the limit of r to the power n, where n goes to infinity, is 0. Therefore the sum to infinity equals to a over 1 take away r. But if the modulus of r is greater than 1, then the limit of r to the power n, where n goes to infinity, is equal to infinity, so that the series does not converge. Next we learned about arithmetic mean. So if three numbers p1, p2, p3 are in arithmetic progression, then p2 is called the arithmetic mean of p1 and p3. So that is the arithmetic mean of two numbers x and y is half of the addition of x and y. Then we learned about geometric mean. If p1, p2, p3 are in geometric progression, p2 is called the geometric mean of p1 and p3. That is the geometric mean of two numbers x and y is root of x times y. So if you like this tutorial, press the like button. Also, if you have any question, please put them in the comments below. And subscribe to this channel to get instant access to the tutorial. For all of that and more, I'll meet you in the next tutorial. Thank you.